right, welcome to day 7, our review day. So there's your homework answers. You can pause the video at this point and check those answers, and then skip ahead into the worked out solutions of any ones that you got wrong. So here's your worked out solutions. I'm mainly going to talk about in each of these the restricted domain. So you can pause where needed to look at the solution. So in number 1, in getting y by itself, one clever thing you could do. So right before this star here, if you have two things equal to each other, the reciprocals are also equal. So I flipped the left fraction and also flipped the right fraction because that just made it easier to be getting y by itself. Then I could multiply the -2 over and square it, and that helps me get y alone. So now our restricted domain, x had to be less than 1, and here's why. So x can't be 1 because it would make the denominator 0. So we had to pick a side for it based on our initial condition. And our initial condition was x equal to 0. So we need to be on the left side of 1, so x is less than 1. Now, one thing we would just want to spot check is in our differential equation, we had a square root and then cubed for y plus 2. So y plus 2 needs to be a positive. And whenever, here's our y value down here, y is equal to the 4 over x minus 1 squared minus 2. Whenever x is less than 1, we're going to get something in the denominator that will make it so that y has to be greater than 2. So essentially, since the denominator squared and you have 4 divided by it, we're going to have some positive value for that first term. There's no way for that first term to be 0 or negative. So because the first term has to be something positive, then when you subtract 2, it guarantees us that the y value will be bigger than -2. So that kind of takes care of itself for the differential equation. So again, here is 2. You can pause where needed in 2. So for the domain, if you factored the bottom out, 1 and 7 make the denominator be 0. So we need either less than 1, between 1 and 7, or greater than 7 to have an open interval, and it's got to contain the initial condition. Well, we had x equals 2, so that's what we wanted between 1 and 7. For 3, we have no issues in the original differential equation because e to the 2y will never be 0. But in our natural log, we need that inside to be positive. So we need x cubed. We need that to be greater than -e over 2. Because if x cubed is -e over 2, that'll make it be 0. And if it's greater than that, then it won't be. So if x cubed has to be greater than -e over 2, that means x needs to be greater than the cubed root of -e over 2. And we're greater than a negative number, so our initial condition of 0 is on that interval. So again, you can pause anywhere needed. For the natural log, we need the inside to be positive, so we need to either be, it's 0 at -2 and 2. In between, it's negative, so we need to either be left of -2 or right of +2. Well, square root of 5 in our initial condition is right of +2. That's why we have x is greater than 0. Pause where needed for 5. So I think it's easier to think about where I put the blue arrow there. So you've got your absolute values. We resolved them with the initial conditions. Well, in our initial condition, the y was a negative, or sorry, the y was a positive and the x was a negative. So when you put 1 in for y, since it's going to give us a positive thing, we can just take the thing inside the absolute value. But because our x value is negative, that absolute value of x becomes a negative x. And then you can go through and solve from there. Um, we need our, uh, we could not have x equals 0 because in the original differential equation, x was in the denominator. So we had to pick which side of 0. We're in our initial condition, we have x is -1, so that's why we wanted less than 0. And for each of these, they weren't restricted domains, so I'll just pause. You can just pause where needed for any of the ones from the multiple choice. So on the review sheet, we're going to just go over a couple of them, and any others you have questions on, you could come to office hours. We're going to start out, we're going to go over 3A. So we'll start out, we'll separate. So we'll have y dy, add the x over and multiply the dx over, so you have e to the x dx. We'll take our integral of both sides. We'll get 1/2 y squared is equal to e to the x plus c. We'll sub in our initial condition to resolve the c. Over on the left, we'll have a 1/2 times 4, so we get 2. This will just be 5. And when you subtract the 5 over, we'll get c is -3. So we really have 1/2 y squared is equal to e to the x minus 3. We'll multiply a 2 over and take the square root, and we'll have y is equal to plus minus the square root of 2e to the x minus 6. We resolve our plus minus with our initial condition. Our initial condition had a negative y value. So we would want y equals minus the square root of 2e to the x minus 6. We've now got to think about if we have to restrict our domain. In the original differential equation, no denominators, square roots, logs, so nothing we have to worry about there. In our final answer, we've got the square root. We've got to make sure that's non-negative. Well, the inside would equal 0 if e to the x was equal to 3. So we want e to the x to stay greater than 3 to keep that positive. If we take the natural log of both sides, natural log of e to the x becomes x, so we would want x to stay greater than natural log of 3. And our x value in the initial condition was natural log 5. Natural log 5 is greater than natural log of 3. The next one I wanted to look at was number 5. So a rumor spreads among a population. There's n people, and it's spreading at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. That sentence there is basically the definition of our logistic function. And our differential for a logistic function, we just got to make sure we get our variables to match up. P denotes the number of people, so that's like our y value. And then we have t as time. That will always equal some constant times whatever your y is represented as, so people, times your carrying capacity, which is the total number of people we have here, minus your y value. Because P is representing the people that know, N minus P is representing the people that still don't know, because it's the total minus the people we know. And then we have some constant there. So that's just coming directly from what we saw a differential equation looks like for a logistic function. So the next one I wanted to talk about was 8. And we're not going to do the whole thing, but when you get down to restricting your domain, you can use your calculator to help you restrict that domain. Okay, the test will, or the quest will be no calculator, but I'll just give you one that you can do on the test, restrict the domain without a calculator. But it is okay for you to restrict that domain and just keep it out to 3 places, whatever it is, using our AP rounding standard. And then the last one I wanted to look at was 11. So we've got a slope field for a differential equation, and we want to know which of these could be the solution with when our initial condition is, and that's an equals, y of 0 is equal to 1. So that means we have the point 0, comma 1, which is right here. And if we kind of sketch in with our slopes what it would look like, it would look something like that. So that's something like that should be our initial, should be our solution. So let's go through and see which of these would make sense. So cos x, okay, it starts at 1 on the y-axis, so that seems reasonable. But cos should hit the x-axis at pi over 2. Pi is 3.14, so pi over 2 is a little bit bigger than 1.5. And this is not going to hit the x-axis at 1.5. Notice by these really flat slopes, our solution should level off at the x-axis. It's not going to go through it. 1 minus x squared should be a parabola that's upside down and shifted up 1. So we've got the shifted up 1 part, but it should have roots at -1 and 1, and we're not going through that. This is not e to the x, because e to the x would keep growing. Square root of 1 minus x squared. Well, as x becomes large, the y values, or the y values would not exist anything past x equals 1. So this would not end up working out. And it might be easier to recognize what that is what if we squared both sides? That'd be y squared equals 1 minus x squared. Add the x over, that's x squared plus y squared equals 1. Well, hopefully you can recognize that's a circle centered at the origin with a radius of 1. So, and the square root is a positive square root, so it'd be the top half of a circle. This is not the top half of a circle. And then lastly, hopefully this will work out. We have 1 over 1 plus x squared. Notice that should always be positive, which ours is going to be. As x becomes enormous, the y values are going to get really small because the denominator will get big. And when x is 0, it does give us 1 back. So it looks like E will work out for that. So the rest of the day, your task is to work through that review sheet. It will be on office hours if you wanted to come and get help on any of those. Have a great rest of your day.